Least square method. It is a statistical technique that investigates the association between dependent and independent variables. This method determines the line of best fit for a set of observations by minimizing the sum of squares of the vertical deviation between actual points and regression line. If there is only one independent variable, the analysis is known as simple regression. If the analysis involves multiple independent variables, it is known as multiple regression. In the method of least square, the deviation is the difference between the predicted and actual cost, and you have to apply this formula. Okay? Summation of y is equal to NA plus B summation of x. A na bex. Okay? Summation of xy is equal to A summation of x plus B summation of x squared. Xc, exa, bex, bex. Okay, so take note of that. A na bex, xc, exa, bex squared. Okay? Where summation of y is the sum total of all cost of all samples. N is the number of samples. A is the total fixed cost. So this is derived from the equation y is equal to A plus bx, okay? Which we have discussed in high-low method. B is the variable cost per unit. Summation of x is the sum of activity levels of all samples. Summation of xy, sum of total cost multiplied by activity level of all samples. And summation of x squared is the sum of activity levels squared of all samples. Okay? So to illustrate the least square method, the following activity and cost data were provided by Kenny Corp. Okay, that would help in estimating its future maintenance cost. So if there are 3 units produced, the maintenance cost amounted to 450. 7 units, 530 pesos. 11 units, 640 pesos. And 15 units produced, 700 pesos. Now, using the least square regression method, the expected total cost for an activity level of 10 units would be. So you have to compute first, okay? Applying the least square regression, the formula, okay? And applying the formula, okay, we can now compute the expected cost for 10 units produced. So with regard to the number of units, that is your X. Okay? 3, 7, 11, 15. With regard to the Y, which is your cost, so this is your peso value, 450, 530, 640, 700. So this is step 1. Okay? Now step 2, you have to multiply, okay, X and Y to get XY. Okay? Then sum it up. So you have here summation of X, Y. Okay? And step 3, 3, 7, 11, and 15, you have to square this number of units. Okay? X. So X squared. And you have here summation. Okay? And that is your X squared. So we're done with summation of XY. Okay? Summation of X squared. Then you sum up X. Okay? And sum up Y. Okay? Then you apply the formula. Okay? A na bex, summation of Y, that is 2, 3, 20. NA, number of units, 1, 2, 3, 4. So there are 4. Okay? So N is the number of samples. Okay? There are 4 samples. A, that's your fixed cost, plus 36. Okay? B, And this summation of x, okay, we have here 36, okay, and b. So this is your y is equal to a plus bx, okay. So you have here summation of y again is 2320. Summation of b, rather x is 36, okay, and you have n is the sample for and a and b, okay. Same goes with xc, exa, bex, bex. So you have summation of xy 22,600 is equal to summation of x, that is 36, a, okay, and summation of x squared 404, b. So after plotting this formula, okay, you have to multiply, okay, a certain number to cancel either a or b, okay. In this case, it would be easier to eliminate a, okay, considering the lower number of unit, okay. So 2,320 is equal to 4a plus 36b times negative 9 to get, okay, negative 36a. Okay, and negative 9 times 2,320, that is negative 20,880. And negative 9 times 36b, that is negative 324b. Okay, this time you can cancel 36a negative and 36a positive. Okay, you can also, okay, reduce 324 from 404 to get 80b, and 22,600 deducted by 20,880 to get 1,720. So we can now compute b. So 1,720 divide this by 80. So b, okay, and that is your variable cost per unit is 21.5. At this point, b is already determined. The next step is to determine the value of a by substituting 21.5 to b at any of the two equations. Say for example, okay, we choose 2,320 is equal to a plus 36, 4a plus 36b. So multiply 36 by 21.5, deduct it from 2,320, okay, and divide this by 4 to get a, the amount of fixed cost. So in this case, okay, we have here 2,320 is equal to 4a plus 36b, which is 21.5 times 36, 774. Deduct it from 2,320. Okay, you get 1,546 is equal to 4a. Now a, divide this by 4, okay, to get 386.5 as your fixed cost. So your equation now, y is equal to a plus bx is equivalent now to y is equivalent to 386.5 plus 21.5 b. Okay. This time, your b is 10. So 10 times 21.5, that's 215 plus 386.5. So you have here 601.5. This is your total cost, maintenance cost, okay, at 10 unit produced. Okay, so that's how you compute using the least square regression. Let us illustrate further high-low and least square method. So green company's total overhead costs at various level of activity are presented below. For March, April, May, and June, we have here the machine hours. 500, okay, machine hours producing 970, okay, overhead cost. 400 machine hours incurring 851 overhead cost. 600 machine hours producing 1,089 overhead cost. and 700 machine hours, we have 1,208 overhead cost. As we all know, with regard to the overhead, there is variable, fixed, or mixed portion. Okay? The breakdown of overhead costs at April 400 machine hours is as follows. So we have here 260 of the 851, okay, is variable. So 260, divide this by 400 to get the so-called variable cost per unit. Salary, it's fixed. So per total, it's fixed. Okay? And utilities, this is mixed. So you have to apply high-low method. Okay? High-low method. Or least square regression. Okay? Or you can also use, okay, the total overhead to apply these methods. Okay? Because again, it can be determined through high-low or least square, okay, depending on whether we apply the cost function for utilities in specific, okay, or cost function for total overhead, okay, in total. Okay. Now, using least square method, determine the cost function for total overhead. So we apply the least square here, okay, total overhead. While for high-low, the assumption now is either at utilities, okay, we segregate the variable and fixed portion for the mix, or in total. Definitely, we will be computing different cost function. And as we have discussed, the cost function is y is equal to a plus bx. Okay? And what would be the total overhead cost if operating level is at 450 machine hour? It means that after determining the cost function, you just apply, okay, this 450 machine hour as your x, okay, then you can now compute for the total cost, okay, depending on whether we apply high-low method or least square regression. Now, using the high-low method, again, supply, salaries, and utilities, okay, 851 is allocated to 260 for supplies, 300 for salaries, and 291 for utilities. So we have here 260 divided by 400 machine hours, so 0.65 per machine hour. At highest cost, okay, 1208, okay, 455 variable cost for the supplies. So this is 0.65 times 700, so that's 455, okay? So we apply the variable cost per unit, which is fixed on a per unit basis if variable. But on a per total, it varies. Salaries, it is fixed at 300. So same. That is why we segregate now the utilities. Okay? The variable and fixed portion of utilities. So 453, we're going to use 453, okay, at 700 machine hours, the highest, okay, activity, and 291, okay, lowest cost at the lowest activity. So HICO, LOCO, okay, highest cost, okay, minus lowest cost over highest activity, HALA, okay, lowest activity. So we have here 0.54. Okay. So after computing the variable cost per unit for utilities, we can now compute for the total fixed cost. Okay. So we have 0.54 times 700. Okay. Deduct it from the total cost of 453. So your fixed cost now is 75. So this is y is equal to a plus bx. Okay. So your b is 0.54. Okay. Your y here is the total 453. So in computing now for the a, which is the fixed cost, okay, we have computed 75. That's why the cost function now is y is equal to 75 plus 0.54x. And this is for utility in particular. Okay. So to classify again, Supplies, variable. Okay, total cost, not necessary. Cost per machine hour is 0.65, fixed. In total, 300. Cost per machine hour, not necessary. Utilities, 75, fixed portion. And the variable portion, 0.54. Okay, so you have here 375. Okay, and the cost per unit is 1.19. Okay, now, we can also use the second assumption, the total overhead cost. Instead of in specific utilities, on per total overhead, we have highest cost, HICO, minus LOCO. Divide this by highest activity minus lowest activity. Hala. So 357 over 300, that's 1.19. Okay, and 1.19 multiply this by 400, lowest activity, deduct it from the cost, 851. So we're going to work back 375 as the total fixed cost. Therefore, the cost function is y is equal to 375 plus 1.19x. And that is, okay, the total overhead cost function. And this is the same, okay, format or amount as we have used the so-called utilities. Okay, so the fixed portion, okay, and fixed portion of total cost or mixed cost, and the variable cost per unit for supplies, the variable cost per unit for utility. So 375. So y is equal to 375 plus 1.19x. Okay? Or just simply use the total overhead cost. Okay, so take note of that, but make sure that there is no outlier. Now, applying the least square regression, okay, A na Bex, XC, Exa, Bex, Bex. Okay, step 1, sum up your X or samples. Okay, so you have 1, 2, 3, 4, 4 samples. Okay, and the summation of X is 2,200. Okay, then for Y, sum up. So the summation of Y, okay, is 4118. Then multiply this. Okay, so you have step 3, multiply to get XY, and step 4, square, step 1. Okay, then after applying this, so sum up, use A na Bex, XC, Exa, Bex, Bex. So A, summation of Y, 4118. Okay, na, N is the number of sample, 4 samples. A, okay, that's fixed cost. Bex, B, and summation of X, that is 2, 2. Okay, so we're done with the first formula. And XC, summation of XY, so 2, 3, 2, 4, 400, plus summation of X, okay, that's 2,200, A, and Bex squared. So B, okay, and 1,260, that's the X squared. And again, multiply a certain number, okay, to cancel A. So negative 550 multiplied by 4A to cancel 2,200A. Okay, and the negative amount of 1 to 10,000 B, deduct it from 1 to 60, you have 50,000 B, and 2 to 64900. Okay, it is computed by multiplying 4118 by 550. Okay, negative, and this negative amount will be deducted from 2,324,400 to get 59,500. Okay, and B, okay, shall be computed by dividing 59,500 by 50,000 to get 1.19. So that is your variable cost per unit. Okay, so the fixed cost per unit, applying the formula, okay, 4118 is equal to 4A plus 22 times 1.19. So you have 4118 deducted by 2618. So that's 15. Divide this by 4. So A now is 375. So the cost function per total is Y is equal to 375 plus 1.19x. The same with regard to highest cost and lowest cost, high-low method. Okay? Now, the total overhead cost at 450 machine hours, applying the formula, just multiply 450 by 1.19 plus 375. The total cost now is 910.50. Okay? So that is for least square regression. Now, for the other methods, we have scatter graph. You have to plot in a diagram or graph all observed costs at various activity levels, okay, are plotted on the graph based on the sound judgment. So this is subjective, no? A regression line is then fitted to the plotted points to represent the line function. Its principal advantage over the high-low method is that it considers more than 2 points. The major objective of this method is to develop an equation to predict future cost. Engineering method. This method is best used for estimating costs for totally new activities. It can detail each step required to perform an operation and sometimes can be quite expensive to use. Account analysis method. Each account is classified as either fixed or variable based on experience and judgment of accounting and other qualified personnel in the organization. And last, the conference method. Costs are classified based on opinion from various company departments such as purchasing, processing, engineering, manufacturing, employee relation, and so on. So these are the methods, okay, in segregating mixed cost as to the fixed portion and variable portion.